absolute value functions. In this lesson, we're going to talk about how to solve absolute value equations and inequalities, and how to graph absolute value functions. So let's start there. Let's start with graphing absolute value functions, and we're going to start with our most famous graph, or most basic graph, I should say, f of x equals x, the identity function. So I like to graph that by just going y equals x plus 0. So now it's like, oh, that's my y-intercept, that's my slope. So it's an m plus b form. So I'm graph along like that, right? I start with the y, so my y-intercept is at 0, go to 1 and 1. So there's the identity function, straight to the middle. And now let's graph the absolute value of this function here. So we're going to graph the absolute value of f of x. So you take the absolute value of this side, which would just be absolute value of x. Now you might know what this graph looks like already, but let's talk about where that comes from. Right, absolute value is a distance measurement, and distance is always positive. So I could plug any number I want in for my x. You can use the left side, right side, it's all good. But the numbers that come out of absolute value function are always positive. So what it does here is it moves the negative part of the graph, it flips it to the positive side. So my graph's going to look like this. And that's the absolute value of x. So that's where that graph comes from. And that's how you, in general, that's how you graph an absolute value of a function. Whatever's on the negative y value, make it a positive. So you can see with this next example, right? Here's a quadratic form. Here's a quadratic equation with the vertex at 4, -3 right there. And then if you want the absolute value of it, that's what this one is right here. You can see they died right there. All that happens is all the stuff that has the negative y flips up to the positive x. So that's how you take it. That's how you graph an absolute value of a function given. So they give you a function, you want the absolute value version of it, copy it, except for make anything that's on the negative side, make it positive. Can you get that? Okay, now the question on this one is, let's talk about the domain and range of both of these, and what the absolute value does. So the domain here, farthest left arrow, farthest right arrow, negative infinity, positive infinity. My range, look at the lowest we go. -3 is the lowest I go. And then highest arrow, infinity. So we're going to go -3 to infinity. Now when you do the absolute value of it, my domain doesn't change. Left and right is the same. I can change my domain, but my range will change. But look at the lowest now. Since everything I move positive, I should never have a negative. If you're doing absolute value, you're not going to have a negative answer in the range. It's going to go from 0 to infinity in this case. It doesn't have to go from 0, but it has to be something positive for sure. So that's the domain range, right? So make the negative part, start the positive part. Moving on. So this one, here's our graph of f of x, and it wants to graph the absolute value of f of x here. So you see f of x, and I want to graph the absolute value of f of x. Now, the stuff that's positive, as you can see here in blue, not going to change at all. So my graph is still going to go from, 3,0 to 6,3. That part's not going to change. This part, though, the absolute value makes all this positive. So if you have points here, we can use the points. That was 1, -3. Now it's going to be 1, 3, because absolute value makes the y value positive. Right? Absolute value makes the y value positive. The point right here, 0, -2 is not going to be 0, 2. And we're just going to try to follow the exact same pattern straight. Right? So that's the absolute value version of this. Right? All it does is it flips all the negative y values to a positive y value. And you get something like this. Hopefully a little better picture than mine. Properties of absolute values. So these are just properties if you have absolute value things. So if you're multiplying two absolute values together, you have two things in absolute value, you can separate them. So for example, if you have the absolute value of 2x, you can see that as absolute value of 2 and the absolute value of x. Same thing with dividing. Right? So if I have 2 over x, absolute value, you can separate that, absolute value of 2 over the absolute value of x, where x cannot be equal to 0. Absolute value of a number is the same thing as the absolute value of the negative one. Right, because absolute value is just how far you are from the origin. So absolute value of 3, which is 3, is equal to the absolute value of -3, which is also 3. And then we have this, what's called a triangle inequality. If you have two numbers, well, as you can see here, if you add two absolute values, it must be greater than or equal to the sum of the absolute value. So if I have stuff like, this is where it comes from, I have stuff like this, that has to be greater than or equal to if I combine them before I add them. Right, because in this case, this is 2, and that's 3, because that's the value of that, makes that 5. And in this case, I get -1 first, and that's the value, that's just 1. So the separate version should always be at least greater than or equal to the combined version. And what is it equal to? When they're both positive, then they'll be equal. Okay, next part. Let's graph this by hand. So they want us to graph y equals 2x minus 1 and the absolute value of y equals 2x minus 1 by hand. Well, we should know how to graph that. Y-intercept of -1, slope of 2. So I'm going to go up 2 over 1. So my graph looks like this. Now I want to graph the absolute value version of that. Well, remember what the absolute value does? It changes all the negative y to positive y. So that's going to be the part right there. Oops. So we hit here and here. It went down to like, my slope is a little off. I don't like that. Slope of 2, right? So I'm trying my slope correct. Alright, so I started here. Since I want to make my slope correct, so I started at that point, I went over 1 up 2. Now the rest of this, right, normally I go down, I have a slope of 2 going this way. Because again, that's absolute value makes that positive. So over 1 up 2, that's more of an estimation. And that's what the absolute value of x. Of f of x, my function there. Let's talk about how to solve absolute. So now we're done with graphing them. Let's talk about how to solve absolute value functions. When you solve an absolute value equation, you should always have 2 equations. So you're going to have the one you just copy, 2x plus 1 equals 7. And then we have the other one, the negative version of this, which is 2x plus 7 plus 1 equals -7. Or statement. Now again, we don't change the sum inside their absolute value. What we change is this. Because what we're really saying is that this 2x plus 1 could be 7. So I can put like a 7 here. And absolute value 7 will be 7, which is true. And I'm also saying, hey, this 2x plus 1 could be -7. If I plug -7 up there, absolute value -7 is also 7. So that's why you don't change the 2x plus 7. That part stays the same. You change what it equals. This could be 7 or -7. Either way, this equation works. So then you just solve each one separately. Subtract 1, 2x equals 6, divide by 2, x equals 3. Or, solve this one, subtract 1, 2x equals -8, divide by 2, x equals -4. So you have 2 answers, x equals 3 or -4. If you want to solve this with a calculator, we solve by graphing it. So I'm going to read real quick. Right? I'm going to do y1 and y2. So we're going to solve with a calculator and bring out my calculator. Now, the way we do absolute value is you want to hit math and then over the number here. So I'm going to hit math and then number, absolute value. Now, if your calculator is updated, it actually looks like absolute value. If it doesn't, this says ABS. It's the exact same thing. 2x plus 1. And then down here, I'm going to put 7. Now, I want to go to my standard window so I can see it. Standard window should be fine because I want to only go to 7. So I'm going to hit zoom 6 and make sure I'm in standard window. There's my absolute value. And then there's the intersection. That's where 7 is. Remember, the way you find the intersections, you go to second, calculate, intersect. You just want to get close to. So right now I'm at around 0, so I just want to get close to these 2 intersections. Hit enter a couple times. And we get 3, like we got there. And then I could have done that one, I would have got -7. So that's how you solve with the calculator. Anytime you solve with the calculator, you do want to show the graph. It doesn't have to be a perfect graph, just so we have an idea of like, oh, that's how they got it. They used their calculator. So something like that. Just like a little sketch. Okay. So kind of what I did here, how do you solve an absolute value? If it's equal to a number, then you just split it up. Right? The inside of the absolute value equals that number, or it equals negative that number. Same thing we do in inequalities. So if it's a greater than sign, it's the exact same thing, kind of. It's the inside of it, it's greater than k, or the inside of it's less than -k. Where did the less than come from? Well, if you multiply this by negative, right? If you change the sign of this, you have to change the sign of the inequality. Same thing. It actually works the same for a less than sign. You can do a combined inequality that's true. I tend to just do an and statement. I tend to go the same idea. Ax plus b is less than k, and the less than statement is an and statement because it's combined. Ax plus b is greater than -k for the exact same reason as up here. And once you change the sign, you got to change the inequality. So you could do a combined inequality, or you could just do a separate and inequality and then combine it later. So now this is the exact same question we just did, but now we're doing the less than and equal to sign. So just to show you real quick, we'll do a right there. So I'm going to do 2x plus 1 is greater than 7, or, because it's a greater than sign, 2x plus 1 is less than negative 7. Right? Because I changed the sign here, I got to change the inequality. Let me just solve it. X is greater than 3, or 2x is less than negative 8, x is less than negative 4. So there's my solution there. If I was going to do B, it would be 2x plus 1. So again, you keep one the same, is less than 7, and 2x plus 1 is greater than negative 7. We already know the answers here. X is less than 3, and x is greater than negative 4. Now, what's the difference between these two? Well, if you look at the graph here is, you can either be greater than, let's change that. You can either be greater than 3, or you can be less than negative 4. So an OR statement works, it generally goes the opposite direction. An AND statement, this one says you can be less than 3, or you can be greater than negative 4, and they overlap right there. In an AND statement, you're looking for the overlap. So this is my answer. Not the best, it's from negative 4 to 3. That's why if you want, you can combine it, and we get x has to be between 3 and negative 4. That's how that one works. How do you do the calculator? Well, looking for us is the exact same graph. So right here, right? Like I said last time, we already know what the picture looks like, so I'm just going to copy down the picture of the sketch so we have something to go off of. Oh my gosh, it's a little off. It doesn't actually hit at the origin. This was 3, this is negative 4. Right, and this was 7. Alright, so let's look at the A. I want to know where my absolute value function is greater than 7. Look at the picture here, right? My absolute value function is this guy. I want to know when this, I should change the color. I want to know when this orange graph is greater than 7, which is this line right here. Well, where is this thing greater than 7 at? So remember, when we're looking at a graph, it's all about when is it above 7. So when is this above 7? So that happens here and here. Right, so it happens from negative, remember I was looking at the x values from negative infinity to negative 4. I was looking at my thing here from negative infinity to negative 4, and then from 3 to infinity. Also known as when x is less than negative 4, or when x is greater than 3, which is the exact same answer we got here. And then look at the second question, B. Wants to know when 2x plus 1 is less than 7. Well, less than 7 happens. Let me erase some of this stuff I don't need anymore. Light blue. Less than 7 happens, right? When are you less than this line? Well, when you're below it, it happens right in here. Right? This is where the line, the y equals 7 line, is greater than my absolute value line. So it happens between negative 4 and 3. So between here and here. So between negative 4 and 3. Or if you want to say it this way, between negative 4 and 3. So that's how I do it by graphing. I think a lot of people probably find it easier to do analytically, but that's how the graphing version works also. Solve the absolute value inequalities. Solve the absolute value equation inequality. So we've done this before, but it's going to do it again real quickly. So if I want to solve this, notice that they're all the same, so I'm going to do it like fast. If I want to solve this, all I got to do is split it. 4 minus 3x equals 2, or 4 minus 3x equals negative 2. And we just solve each one separately. Minus 4, negative 3x is equal to negative 2, divided by negative 3. X is equal to 2/3. Same thing here. Minus 4, negative 3x is equal to negative 6, divided by negative 3. X is equal to 2. So those are my two values. Now when I do these, I do got to watch out for how the inequalities work, especially since I divided by negative. So I'm actually going to do these a little bit so I know what's going on. So I'm going to split it, right? 4 minus 3x is greater than 2. This is a greater than sign, so I'm going to say or 4 minus 3x is less than negative 2. Right? Since I changed the sign here, I got to change the inequality. I could solve it real quick just so I know which one it is. I'm going to solve it just because also the negative, divided by negative kind of changes this. So I'm going to divide by negative 3. I get x is less than 2/3. And then same thing here. Minus 4 minus 4, negative 3x is less than negative 6. Divided by negative 3. X is greater than or equal to 2. So it's this or that. So there's my answer there. Now you can be less than 2/3 or you can be greater than 2. And if I was going to solve this one, well, now I know how the inequalities work. I'm just going to set it up and go, well, x must be greater than 2/3 and x is less than equal to 2. Right? Since you know what the answers are, you just kind of know how the inequalities work. Well, since I got this on this one, it has to be the opposite on these. That's the way it works. Or you can solve it and solve it. How about the special case? How would I solve the absolute value of x minus 2 equals negative 1? Well, hopefully you notice that absolute value cannot be negative because it's a distance. Negative doesn't work. This is no solution. Absolute value cannot be negative. If I was to graph it to show you, right? So we have math, go over number, absolute value, x minus 2, and then right here, negative 1. Hit graph. Now remember, we're looking for the intersection, and these do not intersect. One's up here, one's down there, so it doesn't work. Now look at the question right here, though. Remember, inequalities are a little different. X minus 2 is less than negative 1. When is my absolute value less than negative 1? That never happens, so again, no solution. If you're trying to solve either of these, you would actually get a solution. It just wouldn't make sense logically. You'd get numbers mathematically that look like they work, but they actually don't work. You have to understand logically, absolute value can't be negative, and based on the graph here, this thing's never less than negative 1. But look at this one. When is x minus 2 greater than negative 1? Well, it's always greater than negative 1. This one should be all real numbers, also known as negative infinity, positive infinity if you want to go that way. If you were to try to solve these analytically, these two, the inequalities, it actually wouldn't work, or you would actually get the same answer, I should say. So like here, remember it's a greater than sign, so it's an or statement, so you get x minus 2 is greater than negative 1, or x minus 2, remember you never change the stuff inside that absolute value, but this will we'll make it a positive one since I multiply by negative, makes it a less than sign. Add 2 here, I get x is greater than 1, or add 2, x is less than 3. Look at that graph. Here's 1, greater than. Here's 3, less than. Remember, it's an or statement. So it's as long as you have one of them, you're good. So it's the whole line. It's all real numbers. And conversely, if I try to solve this one, remember this is a less than sign, so it's an and statement. X minus 2 is less than negative 1, and x minus 2 is greater than 1. So add 2, x is less than 1, and x is greater than 3. Look at that one. There's no overlap, right? And statements need to overlap, so there's no solution here, right? You want to be less than negative 1, and bigger than 3. There's no number that does that, so it's no solution. So if you do it by graphing or by solving, either way, the ambiguous case, the special case where it's no solution, or all real numbers still works. How about you have absolute value on both sides? It's actually not as bad as it sounds. We just treat the exact same way. So if I wanted to solve this, we treat the exact same way. So one of them, we copy it. And then the other one, we negate one side. Now you have to watch out. You want to negate everything. So put a negative on the outside of it. You can see here, right? Negative on the outside. That way, a lot of people they just change the sign of one of them. They forget to change the sign of both of them. So you have to change both sides. Then we just solve. So again, it's a variable, so you just want to put all the variables on the same side, put all the numbers on the opposite side. I get 9 equals x, or shoot with the negative, x plus 6 equals negative 2x plus 3. Put the variables on one side, numbers on the other. I get 3x equals negative 3, divided by 3. X equals negative 1. So again, two solutions. That's how you solve when there's multiple. Solve each equation graphically by referring to the example. So here, look at it, they want us to solve it graphically. So we're just going to graph it on our calculator. So you can see how it looks when you're graphing your calculator. So you go y equals Now this works a lot better if you have a more advanced calculator that could do colors. I don't have that, so I'm just going to work with what we got. Right, so then I go math, number, value, 2x minus 3. Hit graph. So remember that the first thing they graph is the left of y1, which is this one, and the second one they graph is y2. So I have this picture where I have over here somewhere we have this, and then over here somewhere we have this, crossing the streams. Now look what the question is. When is x plus 6, which is my black graph, less than 2x minus 3, which is my purple graph? Now right here they're equal, which is always important, right? That point right there is equal. I should figure out what that point is. Second, calculate intersection. Just hit enter a couple times, and that is at -1. Thought so. So right here is where these two graphs are equal, which I think was the one that was up there. And now I want to know, when is the black graph less than it? Well, right here, everything below -1, it looks like my black graph is less than my purple graph. So from -infinity to -1. And then this one says, well, when is the black graph bigger than the purple graph? It looks like from -1 on is the black graph ahead. So for B, it'd be -1 to infinity, the other side. And that's how we do it. Now this one, solve equation involving sum of absolute value. So absolute value of x plus 5 plus absolute value of x minus 3, 16. We only do this by graphing. So if we ever see a question like this, we'll only do it for now by graphing. When you go higher math, you can do it by hand. But we're going to do this by graphing. So we're just going to go math absolute value, x plus 5. There we go. Plus math absolute value, x minus 3. And then here we're going to plug substitute 16. Now when I graph this, notice how it's 16. So I'm going to hit graph right now, but we're not going to be able to see anything. Well, we're not going to see an intersection because it's all the way up at 16. I got to change my window. So I'll make my window, my y max, 20. So I can see where the 16 crosses. So that first graph is these two put together, and then there is 16. So again, when we solve with the calculator, I like to draw it so we have some reference to what we're talking about. And then we have a graph that goes right here. And then I just want to figure out what these two intersections are. So all I gotta do is press second calculate, intersection. We want to move closer to this side. Hit enter a couple times. You get 7. Again, I don't care about the y, but it's all about the x value. X equals 7 right there. And then do the same to the other side. Second intersection. Press up. Move it all the way over there. Now again, on the calculator, it's a little easier to press second than this. On the computer, it's a lot easier just to scroll. And I get -9. So my answer is x equals -9 or 7. Okay, last couple things. It's basically an application problem. Error tolerances. Absolute values are value quantities can be used to describe errors in quality control. So like these are application problems. So in general, we have this equation. X minus, let's say, y. I don't like the y. X minus a is less than or equal to k. That's our quality control equation, where this is the desired amount slash average. Like this is what we want. Like we want to hit this value. And then the error that we're allowed to have is right here. That's the error amount. Error amount. Or I should say error tolerance. Like that's how much error we're allowed. So this is our x equation. This is our desired amount, what we want to hit with our equation, with our whatever we're doing, and this is the allowed amount of error that we're given. So if we have that formula, we're gonna be fine. As an aluminum can is designed to have a diameter of 2.5 inches with an error tolerance of no more than 0.02 inches. Right now, it's the value inequality that describes the values of D that satisfy this restriction. So that's what we're doing here, right? We're gonna have this equation. And then they tell us that's a bad color. We want the diameter to be 2.5 inches. That's this guy right here. And our error tolerance is 0.02. So here's this formula. Like that. Now sometimes they'll say, I want to know which values it could fall between. So to do that, so I think this is just my answer. Like write an absolute value inequality, that's it. That's my answer. A lot of times they actually want like, oh, what's the lowest, what's the highest it could be. In that case, you just solve it. We know how to solve this. X minus 2.5 is less than or equal to 0.02. Or, actually, and in this case, and X minus 2.5 is greater than or equal to negative 0.02. Right? You leave this alone, you switch this side. When you switch this side, it's an inequality. You change the sign. Then you just solve it. So I get X is less than or equal to 2.52. And I get X is greater than or equal to 2.48. So that's where your X would fall between 2.52 and 2.48. Again, that wasn't the question for this one, but it might be a question in the future. The question for this question was actually just write the inequality, which is this guy. But that's also the error bound we can fall between. Anyway, that's the lesson.